Hi there, Joshua here. So a bit of a strange kind of week, a bit of a bizarre kind of week. A bit embarrassing. I actually burnt myself for picking up a regular hexagon this week. Yeah, I forgot the corners are all 120 degrees. So let's get on with the lesson. Right, in a minute we're going to be rounding some decimal numbers. So before we do that, I need to quickly say something about how we compare the size of two different decimals. So suppose you've got two decimals that are close to each other. For example, 3.42 and 3.418. How do you decide which one's bigger? Well, if you think about how we do it for whole numbers that are close to each other, for example, 7,462 and 7,458, we do it by comparing the digits moving from left to right. So you've got the thousands digits, hundreds, tens and units. So we start on the left at the thousands column. They've both got 7,000s, so you can't tell which one's bigger from that. So you move to the hundreds digits. They've both got 400s, so you still can't tell which number's bigger. So you move to the tens digits. They're different. The top number has 6 tens, the bottom number has 5 tens. That immediately tells you the top number's bigger. You don't even need to look at the units digits. 6 tens is more than 5 tens, so you can stop there. The top number is bigger. So when comparing whole numbers, you compare the digits moving from left to right, and you do exactly the same with decimal numbers as well. So let's do that now. Let's compare these two decimals and see which one's bigger. So have a think to yourself about which one you think is bigger, and then we'll see if you're right. I'll just write the column headings. You've got the units, the decimal point, the tenths, the hundredths, the thousandths. So again, you start on the left at the units column. They've both got 3 units, so you can't tell which one's bigger from that. So you move to the tenths digits. They've both got 4 tenths, so you still can't tell which number's bigger. So you move to the hundredths digits. They're different. The top number has 2 hundredths, the bottom number has just 1 hundredth. So again, that immediately tells you the top number's bigger. You don't even need to look at the thousandths digits. 2 hundredths is more than 1 hundredths, so you can stop there. So the top number is bigger. Right, so before I get on with the rounding, I'm quickly going to talk about the language I'm going to use this lesson. So I've got some phrases up here. Whole numbers are just numbers with no decimal part. So they're like the ordinary counting numbers, like 1, 2, 3, 4 and so on. I've got some whole numbers written on this number line, 3, 4, 5, 6. Other examples of whole numbers would be 7 is a whole number, 28 is a whole number, 386 is a whole number. So they're just numbers with no decimal part. I'm also going to use the phrase 1 decimal place numbers, and by that I just mean numbers with 1 digit after the decimal point. So I've got some 1 decimal place numbers written on this number line. 3.6, 3.7, 3.8 and so on. They've all got 1 digit after the decimal point, so I'm going to call them 1 decimal place numbers. Other examples would be 2.4 or 15.3. And then 2 decimal place numbers would be numbers with 2 digits after the decimal point. So I've got some written down here, 4.79, 4.80 and so on. They've all got 2 digits after the decimal point, so I'm calling them 2 decimal place numbers. Other examples would be, I don't know, 3.81 or 16.04. Right, I've got 3 rounding questions here, and this is just to give you a quick overview of rounding, just to give you an idea of what it's all about. I will go into rounding in a bit more detail after this bit. So let's do the first one. So it says round 5.8 to the nearest whole number. So that just means find the whole number that 5.8 is closest to. So I've got some whole numbers on this, marked on this number line. So it's 5 point something, so it's between 5 and 6. So I'll just split this interval into 10 equal parts, into tenths. So you've got 5.1, 5.2, 5.3 and so on. So 5.8 is just over here, just 2 marks away from 6. So which whole number is it closest to? Well, you can see that it's closest to 6. So 5.8 rounds to 6 to the nearest whole number. So I can write 5.8 to the nearest whole number rounds to 6. That's the whole number it's closest to. Right, let's do the next question. It says round 3.72 to one decimal place. In other words, find the one decimal place number that 3.72 is closest to. We've got some one decimal place numbers here. So which one do you think 3.72 is closest to? Have a think about that. I am going to put 3.72 on the number line. It's 3.7 something, so it's between 3.7 and the next one decimal place number after that, 3.8. So I'll split this interval into 10 parts. And where's 3.72? Well, you've got 3.7, then 3.71, 3.72. 3.72 is there. So which one decimal place number is it closest to? You can see it's closest to 3.7. So I'm going to write 3.72 rounded to one decimal place. So let's write 1 dp, one decimal place is 3.7. That's the one decimal place number it's closest to. Right, let's move on to the next one. Round 4.819 to two decimal places. So that just means find the two decimal place number that 4.819 is closest to. In other words, find the number with two digits after the decimal point that 4.819 is closest to. Again, I'm going to mark it on this number line, but have a think to yourself which of these two decimal place numbers 4.819 is closest to. It's 4.81 something, so it's between 4.81 and the next two decimal place number 4.82. So I'll just split this interval into 10 parts. 1, 2, 3, 4, 1, 2, 3, 4, like that. So where's 4.819? We've got 4.81 here, then it's 4.811, 4.812, 4.813 and so on. So 4.819 is right at the end, just here, 4.819. So which two decimal place number is it closest to? You can see it's closest to 4.82. So I'm going to write 4.819 rounded to two decimal places, 2 dp, is 4.82. That's the two decimal place number that it's closest to. Right, let's do some rounding in a bit more detail now, starting with rounding to the nearest whole number. I'll just do a couple of examples. So let's start with 8.7. So what's that for the nearest whole number? I'm sure a lot of you know the answer already, but I'll just go through the process. So we've got the units digit here, decimal point, tenths digit. So I'm just going to do a little sketch. I'm going to just find the two whole numbers that it's between and then decide which one it's closest to. To get the whole number directly below 8.7, just get rid of everything after the decimal point, just get rid of the decimal part of the number. So you're just left with 8. And then the next whole number after that is 9. So our number somewhere between 8 and 9. Which one's it closer to? Well, clearly it's closer to 9. The number in the middle would be 8.5. Since our number is bigger than 8.5, that means it's here somewhere, so it must be closer to 9 than to 8. So to the nearest whole number, it's 9. So you just find the two whole numbers it's between, and then to decide which one it's closer to, you look after the decimal point. If it was exactly 5/10 here and nothing else, then it would be exactly in the middle. So more than 5/10 it rounds up, less than 5/10 and it rounds down. Let's do another example. Let's do 16.28, round to the nearest whole number. Again, that just means find the whole number it's closest to. I'll just do the column headings, the tens, the units, the tenths, the hundredths. And again, I'm just going to do a little sketch. I'll find the two whole numbers it's between and decide which one it's closer to. So to get the whole number directly below 16.28, just get rid of the decimal part of the number. Everything after the decimal point, just get rid of it. So we're just left with 16. That's the whole number directly below 16.28. The whole number above 16.28 is just the next whole number after that, 17. Which one is it closer to? Well, in the middle you've got 16.5. So is our number bigger or smaller than 16.5? Well, up to the dotted line it's the same, but if you look after the dotted line, you've got 2/10 here, but 5/10 here. So our number is smaller than 16.5, so it's here somewhere. So it rounds to 16. It's closer to 16 than to 17. So the nearest whole number is 16. So you just find the two whole numbers it's between, and then to decide which one it's closer to, you look after the decimal point, more than 5/10 and it rounds up, less than 5/10 and it rounds down. If it was exactly 5/10, it would be in the middle, and you could round either way. You could round up or down. Usually we round up though. So for example, 3.5, if you were to round up to the nearest whole number, 3.5 is exactly halfway between 3 and 4, but usually we'd round it up. So usually we say to one decimal place, 3.5 rounds to 4. Right, let's do some rounding to one decimal place now in a bit more detail. My first one's going to be 8.34. So let's round that to one decimal place. It just means find the one decimal place number that 8.34 is closest to. I'll just write down the column headings. You've got the units, the decimal point, the tenths and the hundredths. I'm going to do it with a little sketch. I'm just going to find the two one decimal place numbers that 8.34 is between and then decide which one it's closer to. So to get the one decimal place number directly below 8.34, just get rid of everything to the right of the first decimal place. In other words, get rid of everything to the right of the tenths digit. So that's just 8.3. That's the one decimal place number directly below. The next one decimal place number after that is going to be 8.4. Just adding 1 to this digit, adding 1/10. So is our number closer to 8.3 or 8.4? Well, it'd be useful to know what the number in the middle was. Now this is a gap of 0.1 or 1/10. 1/10 is the same, if you multiply top and bottom by 10, it's the same as 10 hundredths. So in hundredths, that's a gap of 10 hundredths. So half of that to the middle is just 5 hundredths. So to get to the middle from 8.3, you just have to add 5 hundredths. So that will just be 8.35. Just sticking a 5 in the hundredths column. So is our number bigger or smaller than 8.35? Well, it's a bit smaller because it's 8.34. So you've got 4 hundredths here, which is less than 5 hundredths. So it's a bit smaller. So it's here somewhere. So it rounds to 8.3 to one decimal place. So to decide which one it's closer to, you look after the first decimal place. So you look after the tenths digit. And if it was exactly 5 hundredths, it would be in the middle. So more than 5 hundredths, it rounds up. We had less than 5 hundredths, so it rounds down. Let's do another one. Let's do 14.257 to one decimal place. Again, I'll do the column headings. You've got tens, units, decimal point, tenths, hundredths, thousandths. So again, I'll do a sketch. I'll find the two one decimal place numbers it's between and then decide which one it's closer to. So to get the one decimal place number directly below this number, just get rid of everything to the right of the first decimal place. In other words, just get rid of everything to the right of the tenths digit. So you'll just be left with 14.2. That's the one decimal place number directly below. The next one decimal place number after that is 14.3. Just adding 1 to this digit, adding 1/10. And then which one is this closest to? Well, to get the number in the middle, just add 5 hundredths to 14.2, so that'll be 14.25. So is our number bigger or smaller than 14.25? Well, it's quite close. Of course, up to the dotted line it's the same. After the dotted line, you've got 5 hundredths here and 5 hundredths here, so they're still the same. But then you go into the next column, and you've got 7 thousandths here and no thousandths here. So our number is slightly bigger than 14.25 because it's got 7 extra thousandths. So which tells you that it's here somewhere. So it rounds to 14.3. It's closer to 14.3 than to 14.2. So it's 14.3 to one decimal place. So to round to one decimal place, you find the two one decimal place numbers that your number's between. Our number was 14.2 something, so which tells you it's between 14.2 and the next one decimal place number 14.3. Then to decide which one it's closer to, you look after the first decimal place, after the tenths digit. Now if it was exactly 5 hundredths here and nothing else, it would be in the middle. So more than 5 hundredths and it rounds up, less than 5 hundredths and it rounds down. Our number rounded up because we had slightly more than 5 hundredths. We have 5 hundredths and 7 thousandths. Right, so to finish off, let's do a bit of rounding to 2 decimal places, to 3 decimal places, and maybe a couple of strange ones as well. So let's start with 2 decimal places. Let's do 5.6381. 5.6381. Let's round it to 2 decimal places. So that just means find the 2 decimal place number that's closest to. So I'll just write the columns we've got. We've got the units digit, tenths, hundredths, thousandths and 10 thousandths. Getting very small there. Hopefully that's clear. So I'm going to find the pair of 2 decimal place numbers that it's between and then decide which one it's closer to. To get the 2 decimal place number directly below, just get rid of everything after the 2nd decimal place. So in other words, get rid of everything after the hundredths digit. So get rid of the thousandths and the 10 thousandths as well. So it's be 5.63. The next 2 decimal place number after that is 5.64. Just adding 1 hundredth, so 5.64. And our number's somewhere in between. The number in the middle, to get that, you always go 5 into the next column, so it'll be 5.635. 5.635. So is our number bigger or smaller than that? Well, up to the dotted line it's exactly the same as it always is, but after the dotted line we've got 8 thousandths here, but only 5 thousandths there. So our number is actually bigger than that. So it's here somewhere, which means it's closer to 5. It's closer to 5.64 than to 5.63. So it rounds to 5.64. 5.64 to 2 decimal places. So to round a number to 2 decimal places, you find the pair of 2 decimal place numbers it's between. We had 5.63 something, so it's between 5.63 and the next one, 5.64. And then to decide which one it's closer to, you look after the 2nd decimal place. If it was exactly 5 thousandths, it would be in the middle, but more than 5 thousandths and it rounds up, less than 5 thousandths and it rounds down. Let's do a 3 decimal place one. Let's do 18.1472 to 3 decimal places. So I'll do the column headings again. We've got the tens, units, decimal point, tenths, hundredths, thousandths, 10 thousandths as well. This time we're round to 3 decimal places, so we'll find the pair of 3 decimal place numbers that it's between and then decide which one it's closer to. To get the 3 decimal place number directly below, just get rid of everything after the 3rd decimal place. So everything after the thousandths column in this case. So that would be 18.147. The next 3 decimal place number after that is 18.148. So 18.148, just adding 1 thousandth. The number in the middle, to get that you just go 5 into the next column, so it'd be 18.1475. 18.1475. Is our number bigger or smaller than that? Well, if you look after the dotted line, we've got a 2 here, but there's a 5 here. So that means it's smaller. So it must be here somewhere. So it rounds to 18.147. So to 3 decimal places, it's 18.147. So to round a number to 3 decimal places, you find the pair of 3 decimal place numbers it's between. To decide which one it's closer to, you look after the 3rd decimal place, so after the thousandth digit, and if it was exactly 5 in the next column and nothing else, it would be exactly in the middle. So more than that and it rounds up, less than that and it rounds down. We rounded down because we only had 2 in the next column. Now let's do a couple of different ones just to emphasise another point. So going back to 2 decimal place rounding, let's do 3.402 to 2 decimal places. 3.402 to 2 decimal places. So I'll do this one a bit quicker. So you've got the units, tenths, hundredths, thousandths on a number line. The 2 decimal place numbers it's between. To get the one below, just get rid of everything to the right of the 2nd decimal place. So 3.40. The next one after that is 3.41. 3.41. The number in the middle is 3.405. Just going 5 into the next column. And you can see straight away our number is less than that, because it's 3.402, which means it's here. So it rounds to 3.40. To 2 decimal places, 3.40. Now, is it okay to write 3.4, or should you leave the 0 there? Should you write it as 3.40? Well, I think because you're rounding to 2 decimal places, you should actually keep both digits after the decimal point. Remember, when you're rounding to 2 decimal places, you're looking for a number with 2 digits after the decimal point. So by keeping the 0 there, that shows that you've rounded it to 2 decimal places. Similarly, if you had something like 6.97, and you're rounding it to 1 decimal place, so we've got units, tenths, hundredths. So you'd find the two 1 decimal place numbers it's between. So it's between 6.9, that's the one below. 6.9, what's the next 1 decimal place number after that? Well, if you think of a number line, 6.8, 6.9, 7.0 would be the next one. That's the next 1 decimal place number, just adding a tenth. And the number in the middle is 6.95. 6.95. So you can immediately see our number's bigger than that. It's 6.97, so it's here. So it rounds to 7.0. 7.0. And again, can you just write that as 7, or should you write the 0? I think, again, you should write the 0 to show that you're actually rounding it to 1 decimal place. So to 1 decimal place, we'd say the answer is 7.0. So that's it.